Hello friends, welcome back in once again, and today lecture we will discuss about closure reference cycle. So we are taking here the example from the Apple documentation. So before implementation of the whole example, how it's working, we check some theoretical part of the closure references. So here is the strong reference cycle for the closure. In our previous lectures, we have discussed how classes are strongly referenced with each other and how we can resolve the strong reference cycles between the classes. So in today's lecture we will discuss how closure and classes are strongly referenced with each other and how we can resolve this. So here is the definition. A strong reference cycle can occur if you assign a closure property of a class instance and the body of the closure captures that instance. So it's the definition. According to this, whenever we assign a closure to a property of a class, then this property hold the instance of that class. So whenever we use the property of a class in the closure, we use the self dot some property, because closure call the method on instance such as self dot. We use the self in whenever we use the method or we use the property in the closure. So self hold the instance of the class. So here these accesses case closer to capture self, creating a strong reference cycle. Strong reference cycle because closure like classes are reference type. So here we use the closure is always a reference type and class is also a reference type. So whenever you assign a closure to a property, so you are assigning a reference to that closure. So it's the same problem as the two strong references keeping each other alive. In our previous lectures we have noticed it's the same problems like when one class holding the reference from the other class. So rather than two classes instances, this is the time it's a class instance and a closure that are keeping each other alive. But in the today lecture, here class is holding the reference from the closure and closure is holding the reference from the class, so each other alive and strongly reference with each other. So Swift provides an elegant solution to this problem is called closure capture list. So we will resolve this problem with the closure capture list. So before resolving the problem, so first we will check what is the problem and how it's arising with the closure. So it's the example here and we are implementing this in our example here. So I have already added this code here, so I will check how it's working. So here HTML element is class. We are taking two variables, name and text. So as HTML is a closure, so closure is always a var type, and here we are taking the lazy property. So lazy property will be used at when we use it at the runtime, we'll access the value. So here closure is as a lazy type. So we have already created the lecture, a separate lecture on the lazy property, what is the lazy and how it's the uses. I have given the link of the lazy property in the description box. So before continuing this lecture you can check the link in the description box. So in today's lecture we will not discuss in detail here. So here is the HTML as a closure and here name and text is the variable of the class. And when we used in the closure, so when we use the text self dot name and self dot, so here we are using the self and self holding the strong reference with the class. So class and closure are strongly referenced with each other. So whenever we run it, and here dinit function, so I taking here paragraph is the object of the HTML class is the optional type, and here we are passing two arguments, argument label name and argument label text. So p and hello world is the argument here. So I will try to run it and check what will be the output here. So here you can check that hello world message is printing. So here paragraph.html, so here HTML is returning. So a return statement is working here and returning a string, because this closure is returning a string value from here. So this string is printing here, we are printing with the paragraph object. So when suppose here paragraph is equal to nil. So now we'll check what will happens. So here note any deinitialize method is calling here. So because they are holding the reference from the each other, the diagram we can check here. So paragraph is the object from the class and strongly reference with HTML instance class. So here is the closure is the type of string is returning is strongly reference with the class HTML instance class, and here the text, and here the as HTML is the closure, and here is the text is the strongly reference with self.text and self.name, because self.text here is the self.text and it's the self.name is the two properties from the class we are using inside the closure. So it's a strongly reference with the class. So class and closure is strongly reference with each other, and paragraph is also strongly reference with each other. So here I nil the value of the paragraph, but deinit function is not calling because closure and class is referencing with each other. So they are not delocating the memory. So for this we will use the capture list, the resolution of the cycle for the closure. So here is the solution, how we can resolve this problem resolving strong reference cycle for closure. So we resolve a strong reference cycle between closure and class instance by defining capture list as a part of the closure definition. A capture list is define a rule when using capturing to one or more reference type within a closure body. Capture list is just nothing. We can use the capture list like a array, and here we used self. So resolve this problem we will use the capture list because deinit method is not calling here. So I have created a separate lecture on the capture list, so you can check in the description box. I have already given the link for the capture list also. So here self is creating problem, so we will add the self and add here in. So without in it will not work. If I just add self then it will not work because it's a strong reference. So I will run it and check it will work or not. So you can check that deinitialize method is not calling because here self is a strong reference cycle. So we can check weak for resolution of the strong reference cycle. So if I add here weak, so yes, so conditionally we add here. So weak is a optional type, so it can be value or not, so we add it conditionally. And now yeah, so now I run it again. Yeah, so finally you can check that p is deinitialized. So here deinitialized method is now calling because the strong reference cycle is now removed. So by graphically we look like this. So here we are using unown, but I have added here the weak statement. So after weak the strong reference cycle will be removed also. So we can use unown and weak both for resolving this problem. So here in our example I am using here weak for resolving the problem. So if I use here unown statement, so we simply add here unown, and so I have also created the lecture for the unown and weak, where we should use the weak statement and where we should use unown. So unown is not an optional type when we show that the value in the text and name will not be nil, so we use the unown statement here. So we remove it, and here we remove it because unown is not an optional type. So we remove the condition from here. Yeah, so now I run it again. Yeah, so you can check that here de-initialized method is calling because here strong reference cycle is removed with the unowned, and now the diagram will look like this. Here paragraph is now strongly referenced with the class, but the class and the closure is not strongly referenced with each other. So with the help of the capture list, we can resolve the strong reference cycle of the closure. So I think this will be the helpful. So if you like this video, please like, share and subscribe the channel. Thanks for the watching.